Hello, welcome back to our channel. And this time we have brought to you a very interesting topic that is called as an oscillator. So this is a very widely used circuit or subsystem in electronics design whenever you want to produce waveforms such as sine wave, square waveform, triangular waveform, sawtooth waveform, or any kind of periodic waveform. You basically use the oscillator circuit. And when you produce such kind of waveforms, that acts as a clock or a reference signal to some circuitry in the electronic system. So we basically want to understand what is an oscillator and what is the mechanism about the operation of the oscillator. So as you can see here, the oscillator is essentially an amplifier with a positive feedback or the regenerative feedback. In bracket we are writing in phase. So before understanding what is an oscillator, you want to understand what is an amplifier. So imagine you don't have this block into the system. Only signal block you have from input to the output is what I am highlighting here. So you have input to the system, and you don't have this block also, like I said, and you have input, and that input goes to a gain block, or for example an amplifier, and then you have a output accordingly. And this AOL represents the open loop gain of an amplifier. Okay, so what is an amplifier? So it's basically you apply a small signal here and you have an amplified version of your applied signal. So amplify basically amplifies your signal. Okay, and then amplifier can use your negative feedback essentially. So from open loop system, it can become a closed loop system. Why we need a closed loop system in an amplifier? Because we want to improve the linearity of the output. We want to reduce the distortion in the output signal. We want to increase the bandwidth of amplifier so that the range of frequencies can be amplified without any problem. We want to modify the input and the output impedances so that the amplifier can be driven from the signal source, so any kind of signal source without loading the signal source. And the output impedance of an amplifier can also be modified so that, for example, it can be able to drive any kind of load demanding any amount of current, for example. So that's why we use the feedback. So in the feedback, what we do, you take a portion of the output and then you feed it back to the input, but in between you put a feedback network, and the gain of that feedback network, we call it as a beta. Just like the gain of the amplifier, we call it as a open loop gain or gain simply. There is a gain of the feedback network indicated by beta. So usually this block of amplifier is composed of transistors, and this block of the feedback is composed of resistors, capacitors, or combination thereof. So what you do, you feed this input signal, output signal actually, which becomes input to the feedback network, and then output of the feedback network gets mixed. Here there is a mixer along with the input, it get mixed. So if the input and the feedback signal are in opposite phase to each other, positive and negative, it means your feedback signal is getting subtracted with the input, then it is kind of called as negative feedback. It is called as negative feedback. If the input signal and the feedback signal are in phase with each other, then it is called as positive feedback. Then it is called as positive feedback. Okay. So from input to output is called as forward path. from output to input is called as a reverse path. So that's the basic theory of amplifier without a feedback and with feedback. So when you operate the amplifier without a feedback, you have this kind of expression. It's called as open loop gain, where AOL is the ratio of simply output divided by input. And therefore, the output can also be written as the gain multiplied by the input. So that's the theory. So this is the block, this same block diagram right here can be represented in the frequency domain. So again, what you have here is a amplifier with an active gain, and then you have a feedback, and the feedback is a feedback network is a function of the frequency. That's why you have a j omega here, right? And you can observe that output is becoming input to the feedback network, and input of the output of the feedback network becomes an input to the amplifier, and we don't have any external input here. So that is basically a block diagram of an oscillator. In a moment, I'm going to talk about what is an oscillator. This is a block diagram of an amplifier with feedback. Okay, and the same block diagram can be converted into an oscillator. So just I mentioned what is an oscillator. So if your amplifier system utilizes a negative feedback, that means the signals, input signal and the feedback signal are out of phase to each other, it's an amplifier block. It is called as degenerative feedback. Okay, out of phase feedback. However, if you have input signal and the feedback signal are in phase to each other, in which we say the feedback is regenerative feedback. Okay, it is regenerative feedback or a positive feedback, then the same amplifier block can oscillate. Your oscillation can happen here, right? So you don't need an input signal also. You then have a look at this block diagram, right? So in amplifier you have an external input signal. However, in oscillator you have no input signal, no external input signal. But then how this block will work as an oscillator without any input? How will you have a simple waveform, maybe a sinusoidal or a square wave, or let's say triangular or a sawtooth waveform, etc., right? Or simply a train of pulses. So without the feedback, so is basically what you do, you can make the system acts as an amplifier as long as your feedback is negative. But if the feedback becomes positive, you can make the circuit oscillate. And when you use the system or circuit as an amplifier, you want to use it as an amplifier. You don't want it to oscillate. But when you want the system or circuit to oscillate, to be used as an oscillator, then you design a feedback in such a way that you satisfy this destination. There is a positive feedback. Okay. So let us first understand how the amplifier system will work with the closed loop, right? So I just now explained to you that the circuit is going to work in a open loop, but what about the closed loop? So let's say you have this input signal Vn, then you have this output signal V out, and this is an input. V out is an input to the feedback gain, feedback network, and the output here, let's say you have Vf, which is beta times V out, right? And then here you have this signal V error. V error is basically V in minus Vf. Okay, so let us write that one by one. So what we write here, the gain in this case now will be the closed loop gain, right? So we can write here the expression for the closed loop gain. So ACL, again, it is output divided by input. But the input now is VE, VE or V error. And we know that V error is basically V in minus Vf. And Vf is beta times V out. Okay, so you have these expressions. So just type the values, type in the values here, right here. So ACL can be written as, let's say, uh, you have like VO divided by uh, V in minus VF. Okay, and then you can write here ACL again, that is equal to VO divided by V in minus, what is the value of VF? It is beta times V out. Okay, so we basically are putting the values here. So again, the closed loop gain is the ratio of output divided by input voltage, and the V epsilon or V error is V in minus VF, and VF is beta times V out. So ACL will be VO divided by V in minus VF, and therefore it is VO divided by V in minus value of VF, that is beta times V out. So you can just solve it. So here it goes ACL V in minus beta times V out is equal to VO. And then simplify it further, ACL times V in minus ACL times beta into V out is equal to VO. And then you have ACL times V in is equal to, taking this side to the right hand side, VO plus ACL into beta into V out. Okay, and can we actually, so this is V out actually, okay, this is V out. So here is also V out. So V out can be taken common from this term. So let me write here, your ACL into V in is equal to, V out is taken common in bracket, then 1 plus beta times ACL. And that's it. So you have like uh, what what can we do here? Is there anything we have missed out? Well, let me write here, ACL is equal to VU. Okay, just a second. Right, so we can finally write V out divided by V in would be ACL, that is a closed loop gain, divided by 1 plus beta times ACL, right? So, well, ACL is not the closed loop gain. Actually, it is going to be open loop gain, right? So let me have that correction. So it is always open loop gain. So don't get confused with that. Okay, so it is open loop gain, always there, AOL. Okay, so finally you see, if you take the magnitude, it is equal to AOL divided by 1 plus beta AOL. And if your feedback is positive, then this denominator term will become A1 minus beta times AOL. So that's in the case of oscillator, the circuit will oscillate. Okay. So now how the oscillator is going to work, that is the question here, how oscillator works. So have a look at this. You don't have any external input. So when you switch on the DC, there is a noise actually present in the system. So that noise circulates around the loop. It gets amplified by the amplifier. And again, this feedback network's job is to filter out a single component of the frequency and rejecting others. And that single component again becomes an input. Again, it is amplified by this amplifier. Again, that comes out to as an input along with the other frequency, and the filter here will again select only that signal frequency. And the magnitude of the oscillation will keep on increasing. And then that's how you basically start with the lower magnitude of oscillation and then sustained oscillation. Okay, there is a constant oscillation established. So that is how basically your oscillator will work. So here is a circuit diagram of a simple example. You are using an inverter. You see there is no external input here. So you use the feedback network of resistance and capacitor. Your output voltage is a square waveform, a train of pulses, and that train of pulses is becoming an input to the amplifier, but your resistor and capacitor networks acts as a integrator here, and the voltage across the capacitor then is your triangular waveform, which is becoming an input, and the cycle continues here, and you have a stable square wave as a clock. So there are types of oscillator: linear oscillator, such as sine wave, and there are non-linear oscillators, which gives you square wave, triangle wave, or pulses of a variable or constant width. Okay, so I hope you understood the basic principle of oscillations, how it works, and a block diagram way, and how amplifier can be used as an oscillator. But you don't want amplifier to be used as an oscillator, rather you want to avoid it. But when you purposefully design the oscillator, you actually have a positive feedback, which is called as regenerative feedback, which adds to the input signal and closing the loop. And we got the expression for the oscillator. So click the like button if you like the video. Put some comments as your opinion. Share this video with others for a wider reach. And stay tuned for more engaging contents like this. Till then, wish you happy learning.